When working with graphs, we'll be dealing with two common variables, x and y. Relation is a connection between two variables. One variable will always be dependent on the other. Identify the independent and dependent variables in the following situations. The mass of a frozen turkey and its price. Which is independent, which is dependent? The price depends on the mass of the turkey. Mass doesn't depend on the price. Like if you haggle to a lower price, the mass of the turkey doesn't change. The independent variable is the mass, and the dependent variable is the price. Price depends on the mass. You start with the mass first, you get the price after. Price depends on the mass. Another relation, the area of a room and the time it takes to paint the room. The time it takes to paint the room depends on the area of the room. If you suddenly take less time painting, it doesn't mean that the area shrunk. The independent variable is the area of the room, and the dependent variable is the time it takes to paint. The time it takes to paint depends on the area. Painting time depends on the area. These were examples of relations because there are situations where two variables were somehow connected to each other. X is always independent and y is dependent. These were examples of relations because they were situations where the two variables. These were examples of relations because they were situations where two variables were somehow connected to each other. Variables x and y. The variables are connected. X is independent and y is always dependent. This is important when a relation needs to be represented by a table of values or by a Cartesian plane. A relation between two variables is said to be a function or functional when each value of the independent variable is associated with only one value of the dependent variable. Each independent is mapped onto one dependent function, has to be either one-to-one or many-to-one. I always think of a blender. You can put in one ingredient, blend it up, you're going to get one thing out. You're going to get some kind of smoothie out. But if you put in 5 ingredients, you're still going to get a smoothie out. It's always one-to-one or many-to-one, and that's a function. If you have a non-function, that would be one-to-many. If you put in a banana into the blender and blended it, you get banana mush out, that's one-to-one. But if you got banana mush out and a small car, that would be weird. That's not a function. In this example, notice that we have 30 gets us 1, 30 also gets us 9, all right, 21 gets us 3, and 21 also gets us 7. So that's 1 to many, so that makes it a non-function. If it's 1 to many, x repeats, it's 1 to many, it's a non-function. In this example, for every x, there is only one answer for y, one y value. This is a function, the x does not repeat. This is a many to one. The reason why it's many to one and not one to one is the negative 7 gets us 34, also the negative 3 gets us 34. The negative 6 gives us 10, and the negative 4 gives us 10. So that's many to one. In this situation, this is a function. The x does not repeat. That's why it's a function. It is 1 to 1. We could also do the same thing by looking at the graph, and this is called the vertical line test. If you have a graph, if you draw a vertical line through it, the vertical line only touches it once right there. This is a function. This is a many to one function. You would have two x values that get you the same y value. A y value here and a y value there. So two different x values would get you that y value. If you look at the x-axis, when x is negative, this is negative 5. So when x is negative 1 point something, you get 0. When x is equal to positive 0.2, you're getting 0 as well. Two different x values give you one y value, many to one. Vertical line test, no matter where you put the vertical line, it's only going to pass through once. You have a little asymptote here, which means this value can never be equal to 2. So no matter where we put this vertical line, it's only going to cross through once. This is a function, it's 1 to 1. If we draw a vertical line, if we put the vertical line here or here, or anywhere over here, anywhere except on the vertex, it's going to pass through twice. Okay? So that means it is 1 to many. It's not a function, it's 1 to many. Vertical line test, if you draw a vertical line, if it passes through more than once, it's not a function. If it passes through exactly once, it's a function. We can also use mapping diagrams to show a relationship, a relation. Blah, blah, blah. Another way of showing a relation is by using arrow diagrams or mapping diagrams. The first bubble represents the x values. These are also called the antecedents. The y values, the second bubble show you the y values or the f of x values. These are called the targets. The arrows show which x values go with which y values. The 15, the x gives you a 7, And this 15 also gives you 11. This is not a function because it's one to many. Here, these are the x values, these are the y values. The -2 gives us 59. Also, the +2 gives us 59. This is a many to one. Because it's many to one, it is a function. For every x, we have exactly one y. This is a one-to-one function. It's a function, it's function because it's one-to-one. Here's an example. Imagine you have an equilateral triangle. We're saying the perimeter of an equilateral triangle for different lengths of the base. So we're looking at the perimeter of the equilateral triangle for different lengths of the base. In words, we would say something like an equilateral triangle with a base twice as long will have a perimeter twice as long. That's the relation or the function in words. We can make a table of values for this. If the base is 2, then the perimeter must be 6. Makes this equilateral. So if the base is 2, the other two sides are also 2. That's 3 times 2 is 6. If the base is 4, then the perimeter would have to be 3 times 4 is 12. If the base was 6, then the perimeter would have to be 3 times 6 is 18. If the base was 30, then the perimeter would be 90. We can say it in words. We can say it with a table. We could also say it with an equation. We could say that the y, the perimeter, is equal to 3x. We could also graph this. Here I've graphed a couple of points. Y is equal to 3x. That's our graph. Here's an example. Two people are walking towards each other on a sidewalk. At a certain point, one person stops at a bus stop while the other continues walking. The adjacent graph shows the distance between these two people until the arrival of the bus. Here's the graph. They're walking towards each other. Two people walking towards each other. So the distance between them is going down, goes down. Then one person stops at a bus stop while the other continues walking. One person stops here, the other person is walking, so the distance is decreasing still, but it's decreasing slower because one person has stopped. Then they meet, the distance between them is 0. The other person continues, the person that was walking continues to walk. The distance between them is increasing it's the same slope. Here this is -1 and this is a +1 slope. Which of the points A, B, C, or D corresponds to the moment where one of the people stopped walking? B, because the slope changed. The distance between them is decreasing quickly, then it's decreasing by -2 slope. Here, the slope is -1, so one person has stopped. B, what are the values of the independent and dependent variable? The time is independent and the distance is dependent on time. The independent time is from 0 to 18. The dependent, the distance in meters, is between 0 and 16. At what moment do these two people pass one another? They pass one another when the distance between them is 0. It's at point C. At 10 seconds, when the distance between them is 0. F of x. This is a function notation, is the notation for expressing functions as f of x, which was first used by Leonhard Euler in 1734. We would say f of x, function of x, but we would pronounce it f of x. In the equation y is equal to 3x plus 2, we would no longer use the y, we would use f of x instead. The y gets replaced by f of x. If we had a function like y is equal to -2x plus 7, the y gets replaced by f of x. So now we would write f of x is equal to -2x plus 7. If we asked you to find f of 3, all you have to do is replace the x with 3. That would be -2 times 3 plus 7, which is -6 plus 7, which is 1. Or we could say f of -5, and you would replace the x with -5. It's equal to -2 times -5 plus 7, which is 10 plus 7 is 17. We could also say f of x is equal to 10. When y is equal to 10, what's the x value? I would replace the f of x with 10, then solve for x. Subtract 7 from both sides, and that gives us 3 is equal to -2x. Divide both sides by -2, and that gives us -1.5 is equal to x. Or we could say f of x equals -11. Replace the f of x with -11 in the equation, and we have -11 is equal to -2x plus 7. Subtract 7 from both sides. That gives us -18 is equal to -2x. Divide both sides by -2, and that gives us 9 is equal to x. We can put all that in a table of values. Here's our x, here's our f of x, here's all the different values we have. We could graph that. Gives us a nice f of x equals -2x plus 7, or y equals 2x plus 7. And that's it for an introduction to functions. Have a good day.